Hey everyone, welcome back to another lesson in MCV4U. Today we'll be talking about the derivative of y is equal to e to the power of x. So what is e, or this special number e? So it's an irrational number like pi, and again, it's called the natural number or Euler's number. And it's named after the Swiss mathematician Leonard Euler. So here let's take a look at e to the power of x. So it says complete the following table for the function y is equal to e to the power of x using the graph to the right. So here at 0, so take a look at this. At 0, we see here that it would have a value of 1. Yeah. When x is equal to 0, y is equal to 1. And if we draw a tangent line here, what we notice is that the dy over dx, remember, it's the slope of the tangent is the derivative, is also equal to 1. Here, if we look at x, when x is 1, so this graph y is equal to e to the power of x, notice that would provide us with 2.72. And here, so dy over dx, again, which is the slope of the tangent, again, we draw this tangent line, is also equal to 2.72. And here, the third thing here is if we look at, here again, if we look at this third line here, this third line will be, again, at 2. So at 2, we see here that would give us a value of 7.39. What we notice here is if we draw the slope of the tangent line, again, it would also give us the same value of 7.39. So again, remember that dy over dx here is the same as the slope of the tangent. And what's interesting about this here is that what we notice is that the value of the function, so here the value of the function y is equal to e to the power of x at at a given point is the same as the derivative. And so here we see that if f of x is equal to e to the power of x, then f prime of x, or the derivative of that, is also e to the power of x. So it stays the same. Here, if we see that f of x is equal to e to the power of g of x, then f prime of x is equal to e, which is again the same. So e of g of the power of g of x, that would be what we consider the outside. Then we have to multiply by the derivative of the inside, which would be g prime of x. So the derivative outside multiplied by the derivative inside, which has been standard when we've looked at derivatives here. In this case, again, the outside being e to the power of x, and the inside being g prime of x. In Leibniz notation, again, if y is equal to e to the power of g of x, then dy over dx is equal to d over dx e to the power of g of x times d over dx g of x. So again, the derivative of e to the power of g of x times the derivative of g of x. So here we're going to differentiate the following and put it in simplified factor form. So here, if we find the derivative of e to the power of 5x, so y prime is equal to, again, e to the power of 5x, that stays the same, and the derivative of the inside, which is the exponent of 5x, which will be given to us as 5, that's the derivative, which will be equal to 5e to the power of 5x. So get b here, so y is equal to e to the power of x plus 1. So the derivative of that is e to the power of x plus 1, so that stays the same. And then the derivative of x plus 1, which will just be 1. So multiply that by 1. So y prime is just simply equal to e to the power of x plus 1. Here, if we look at y is equal to e to the power of x to the power of 3, here we see that y prime is equal to e to the x to the power of 3. So that stays the same. And then the derivative of x to the power of 3, which is 3x squared. So here we can rewrite this equal to 3x squared e to the power of x to the power of 3. Here, if we look at d, we have y is equal to x to the power of 2x to the power of 5 plus 4x minus 1. So y prime is equal to e 2x to the power of 5 plus 4x minus 1. That stays the same. Then multiply by the derivative of 2x to the power of 5 plus 4x minus 1, which will be nx to the power of 4 plus 4. Here, if we look here, we have x squared times e to the power of x. So here again, we're going to use the product rule. So if, for example, x squared is a and e to the power of x is b, we see here again that y prime will be equal to a prime times b plus a times b prime. So here we see that a prime is equal to 2x, b is just simply e to the power of x, plus a, which is x squared, and b prime, which is simply, again, just e to the power of x. So here, if we take out a common factor of e to the power of x, we'll be left with 2 plus x. So here we have y is equal to, again, cube root x minus e to the power of x. Here we can rewrite this as y is equal to x minus e to the power of x to the power of 1 over 3. Here. So y prime is equal to bring down the outside and then get the derivative of the inside. So here we have 1 over 3 x minus e to the power of x, 1 over 3 minus 1, which is negative 2 over 3, multiplied by the derivative of the inside, which is 1 minus e to the power of x. So here we can rewrite this in a fraction as 1 minus e to the power of x over, we can rewrite negative 2 over 3 and we move it to the bottom. We can rewrite that as cube root. And we have that 3 at the front. So 3 cube root x minus e to the power of x, and that will be to the power of 2 because it is to the power of 2 over 3. So here again, last thing here, we're going to look at the equation of the tangent to the function y is equal to e to the power of x plus 3x over e to the power of 2x at x is equal to 0. And so remember the equation of the tangent, y is equal to mx plus b. Remember the slope of the tangent function is the derivative of the original function. So again, first thing we want to do is we want to find the point, again, because we know that x is equal to 0, we want to find the corresponding y value. So we'll do that first. So we'll find the y value when x is equal to 0. So sub those into our equation. So we have e to the power of 0 plus 3 times 0 over e to the power of 2 times 0. And here we will get 1. So e to the power of 0 is 1 over e to the power of 0, which is 1 as well. So 1 over 1 is equal to 1. So we know that we have a point at 0, 1, which we can sub in after. So second thing we need to do is we need to find the derivative of this particular function. So of y prime. So here we're going to use our quotient rule. So here the first thing we'll find is we'll do the top. We'll keep that same. So here we have, so we'll do the derivative of the top. And so we have e to the power of x plus 3 times the bottom, which here is e to the power of 2x, minus the derivative, or minus the top, which will be e to the power of x plus 3x times the derivative of the bottom, which will be e to the power of 2x, and then the derivative of 2x, which is 2. All over e to the power of 2x squared. So now we can do is we can sub in, again, x is equal to 0. So we know that here x is equal to 0, and we can sub that into our equation, okay, which will equal to 1 plus 3 times 1 minus 1 plus 0 times 1 times 2 over 1 to the power of 2. So that gives us 4 minus 2 when you calculate everything over 1, which is equal to 2. So here we know that our equation is y is equal to mx plus b. We know our slope value is equal to 2x plus b. And we have our point 0 and 1, which we can sub in back into the equation. And we have 1 is equal to 2 times 0 plus b. And therefore b is equal. Therefore b is equal to 1. Hence our equation of our tangent is therefore equal to y is equal to 2x plus 1.